The latest images captured by the James Webb Space Telescope have left researchers astounded. Rather than broadening our understanding of the cosmos, these images have instead highlighted a deeply unsettling truth: our current understanding of physics and cosmology is not sufficient to explain the universe's nature, especially in its earliest stages. These images, which provide insight into the universe's infancy, force scientists to reconsider existing models and probe new hypotheses regarding the universe's origins. The discovery opens a multitude of questions. How did the universe form in such a way? What could account for these new findings? And why are even the most seasoned astronomers struggling to explain them? To begin to unpack the implications of this discovery, let's revisit the concept of the Big Bang, the cornerstone of modern cosmological understanding. Contrary to common belief, the Big Bang wasn't a typical explosion in a pre-existing space. Rather, space itself, along with time and matter, originated approximately 13.8 billion years ago from an extraordinarily dense and hot singularity. A singularity, in the context of physics, refers to a point where gravitational forces become so intense that space-time curvature becomes infinite. The formation of the universe, therefore, was not a mere explosion within an existing void, but the very birth of space and time themselves. The concept of a singularity is fundamental to how we understand the universe's origins. It is from this singularity that the universe has been expanding ever since. Today, we observe the cosmos as an ongoing process of expansion, where the space between galaxies grows continually. However, one of the most critical points to understand is that the universe is not expanding into some pre-existing space. Space itself is stretching. This distinction is crucial for grasping the true nature of the cosmos, and the processes that have shaped its evolution. Following the Big Bang, the universe entered what scientists call the Dark Age, which spanned from the formation of the universe until about 200 to 300 million years later, when the first stars began to shine. The emergence of these early stars marked the end of the Dark Age and the birth of the first luminous celestial objects. These stars eventually clustered together, forming the first galaxies. However, the speed at which these galaxies evolved remains a mystery. Scientists have only recently begun to unravel the details surrounding this process, and a significant clue came through the groundbreaking observations made by the James Webb Space Telescope. In July 2022, experts revealed that the James Webb Telescope had captured images of galaxies that existed as early as 300 million years after the Big Bang. These findings were shocking for several reasons. First, the galaxies observed were much smaller and less massive than those that developed millions of years later. This was entirely in line with scientific models that suggested the density of matter in the early universe was simply not enough to form galaxies as large and massive as the ones we see today. However, these early findings quickly evolved into something far more mysterious. What began as the discovery of 6 bright redshift luminous spots, each appearing to be distant galaxies, led to an astronomical crisis. The 6 galaxies observed were not only more massive than expected, they were almost as massive as our own Milky Way. This raised many red flags, forcing scientists to question their understanding of the early universe. Upon further analysis, experts concluded that these galaxies were located approximately 13 billion light-years away, meaning their light had traveled for over 13 billion years to reach us. These galaxies existed as early as 500 to 700 million years after the Big Bang, far sooner than previously thought possible. To make sense of these findings, scientists studied the characteristics of these galaxies in more detail. They used redshift measurements to calculate the distance and age of these cosmic structures. What they found was both surprising and perplexing. These galaxies were not only extremely early but also massive, far larger and more mature than galaxies observed at such an early stage. In some cases, the galaxies were found to have stellar masses exceeding 10 billion times the mass of our Sun. This defied everything we thought we knew about how galaxies form and evolve. One of the most puzzling aspects of these findings is that even if the mass estimates are correct, the density of matter in the early universe would need to be up to 5 times greater than previously assumed. This raises critical questions about the accuracy of current models of cosmic evolution. How could these galaxies form so rapidly and reach such impressive sizes in such a short span of cosmic time? This challenge has left cosmologists and astrophysicists scrambling to develop new theories and explanations. Some researchers have suggested that these massive galaxies could have formed through processes that remain completely unknown to us, pointing to gaps in our understanding of cosmic evolution. This has led many astronomers to begin questioning the validity of the Big Bang theory itself. The recent discoveries captured by the James Webb Telescope have reignited debates over alternative models of cosmology. These debates highlight the frustrations of astronomers who feel that their alternative views are being ignored by the mainstream scientific community. Some have gone as far as to say that their doubts about the Big Bang theory are often dismissed as eccentric or unfounded. Even scientists who continue to support the Big Bang theory are now confronted with increasingly difficult questions. For example, how could something originate from nothing 13.8 billion years ago? This is a central issue for cosmologists and is often referred to as the creation problem. Was there something before the Big Bang? Or was the Big Bang itself the beginning of everything, space, time, and matter? As renowned physicist Stephen Hawking pointed out, the concept of time itself began only with the Big Bang. This means that the Big Bang could not have been triggered by an event that occurred before it, since time itself did not exist. Another unresolved question concerns the uniformity of radiation and matter throughout the universe. No matter where we look on a cosmic scale, the distribution of galaxies, nebulae, and cosmic radiation appears strikingly similar. This uniformity is a key feature of the current cosmological model, which relies on the theory of cosmic inflation. According to inflationary theory, the universe underwent a brief but incredibly rapid expansion in the moments after the Big Bang, which would have ensured the uniformity we see today. However, some scientists have taken this a step further, suggesting the possibility of chaotic inflation. According to this hypothesis, inflation may not have stopped everywhere. Instead, some regions of the universe may still be inflating, giving rise to what are called bubbles. Each bubble would represent a separate universe with its own set of physical laws. If this theory holds true, it implies that our universe may not be the only one in existence. Instead, it could be just one of many, each with its own unique properties. This idea gives rise to the concept of the multiverse, in which multiple universes exist simultaneously, each with distinct physical laws and constants. If this model is accurate, it suggests that the Big Bang was just one part of a much larger and more complex cosmic structure. In this model, the cycle of birth, evolution, and collapse of universes could be eternal. Such a perspective radically alters our understanding of the cosmos and suggests that the universe we observe may not be the complete picture. Furthermore, the question of whether the Big Bang was the true origin of the universe has been raised by some alternative theories. For instance, one controversial hypothesis proposes that the universe has existed for an infinite amount of time, and that what we perceive as the Big Bang may simply be a recurring event within a never-ending process of cosmic rebirth. This view suggests that the universe's expansion is not a one-time event but part of a continuous cycle. Additionally, some theories from the realm of quantum mechanics and string theory propose that our universe, along with everything in it, might not even exist as we perceive it. According to these ideas, our universe could be a kind of holographic projection, essentially a flat, two-dimensional image projected onto a higher dimensional sphere. While this notion may sound like science fiction, it draws from a theoretical framework known as the holographic principle, which posits that the entire universe could be encoded in a lower dimensional space. If this theory holds, it would fundamentally challenge everything we know about the universe's nature. It would suggest that what we experience as reality is merely an illusion created by higher dimensional forces. This idea has significant implications for our understanding of existence itself, potentially reshaping both scientific and philosophical inquiries into the nature of reality. While the concept of a simulated universe may seem far-fetched, it is worth noting that there are analogies to be drawn between this idea and the Kardashev scale, which measures a civilization's technological advancement by its ability to harness energy. A highly advanced civilization capable of manipulating galactic energy might, in theory, have the capability to create such a simulation. Although this idea seems outlandish, it underscores the fact that as our technology advances, the boundary between reality and simulation could become increasingly blurred. As we continue to explore the cosmos and the fundamental forces that shape our universe, these new discoveries challenge us to expand our views of reality. The James Webb Space Telescope has provided a wealth of new data, revealing the deep complexities of the cosmos. In the coming years, it will be fascinating to see how these discoveries reshape our understanding of the universe's origins, its evolution, and the potential for life beyond Earth. For now, the universe remains an awe-inspiring and mysterious entity, one that continues to elude